Questions 11 through 20 of the 1998 Grade 10 Cayley Math Contest is what I will discuss in this video. If x plus y plus z is 25, and x plus y is 19, y plus z is 18, then y equals. So first you've got x plus y plus z is 25, and then they tell you that x plus y is equal to 19. So we can substitute that into there. So that would give you 19 plus z is 25, and therefore z is equal to 6. And then we use that equation to solve for y. So y plus z is 18, z we know is 6. So solving for y gives you a value of 12. So the answer here is C. A regular pentagon with center C is shown. The value of x is. Okay, the first thing we need to understand is that whenever you have a pentagon, the sum of the angles, the interior angles, is 540. So each angle will have a value of 540 divided by the number of angles of a pentagon. Number of interior angles are 1, 2, 3, 4, 5. So divided by 5, and that will give you 108. So each interior angle like this is 108. Okay? So the next thing to do is to draw a line from the center to the edge there. And that will help us. Now this line right here that I'm going to color red right there divides this angle into two. Now we know that the angle is 108, so when you divide it into two, each of these angles becomes 54. Alright? And very similarly, the same principle holds true for this angle, 54, like that, because this was 108 and this line essentially cut that angle in half. And then this angle is 108. 108, write it over here. So therefore we've got two triangles and we've got everything except x, so we can put all this into an equation. All the angles are 108, this one, plus this 54, plus this 54, plus x, which is right here. All of this is equal to 360 because it's two triangles and each triangle has a sum of 180 with regard to the angles. So you solve for x, and x looks like 360 minus 108 minus 54 minus 54. And this would be 144. So the answer to this is A. A cube, surface area of a cube is 54. What is the volume? Alright, anytime you have a cube, you've got 6 sides, right? And the surface area, SA, is basically the area of these 6 sides. So the 6 faces. And each face is essentially a square, and the sides of a cube are the same. So if you label one side as x, the other side is x, so the area would be x squared. So each face has an area of x squared. So the total surface area of the cube is 6x squared. And they told you that is 54. So there you go. And then solve for this, and you would get 54 over 6 is equal to x squared. So 54 over 6 is 9, x squared, therefore x is equal to 3. Now they want you to find the volume of this cube. The volume of a cube is x to the power of 3. Length times width times height, but in this case all of them are x. and x is equal to 3. So 3 to the power of 3 is 27. So the answer for 13 is D. The number of solutions x, y of the equation 3x plus y is 100, where x and y are positive integers. Okay, 3x plus y is equal to 100. So we'll make a little table here, x, y, and let's see what we get. So let's start with x equals 1. When x is 1, y would be 97. You can just do that in your head. When x is 2, y would be 94. When x is 3, y would be 91, and so on down. So when x is, let's see, we're probably going to get to about 33 if you just keep doing this. If you get to 33 for x, y would be equal to 1. And then at this point, if you start plugging in more numbers like x is equal to 34, y would be negative 2. And they've told us that x and y are positive. So the number of solutions, x, y, are basically those ones listed, and there's 33 of those. So the answer is A. The root of y minus 5 equals 5. 2 to the power of x is 8. What is x plus y? All right, so y minus 5, the square root, is equal to 5. And 2 to the power of x is equal to 8. So we'll square both sides here. So you get y minus 5 is equal to 25. And therefore y is equal to 30. And then on this side, 2 to the power of x is 8. But 8 is 2 to the power of 3. And therefore, looking at this, we see that x is equal to 3. So x plus y is 30 plus 3, which is 33. So the answer to number 15 is C. Rectangle ABCD has lengths 9 and a width of 5. Diagonal AC is divided into 5 equal parts at W, X, Y, and Z. Determine the area of the shaded region. All right, let's draw this out a little bit bigger. So here you have your shape, and we will start to label this now. So they're saying that this is 9 and this over here is 5, these sides, and they want us to figure out this shaded region here, like that. That shaded region. Well, there's 2 of them. So let's just figure out one of them, and then we'll multiply by 2. Otherwise, it'll get a little bit more messy in terms of the diagram. So the first thing that we want to do is concentrate on something they told us in the question, that diagonal AC, which is from here to here, is divided into 5 equal parts at W, X, Y, and Z. Now that's very important to the question, because essentially what that means is that this diagonal is divided into 5 parts, but that means so are the lengths of the width and length. When you draw perpendicular lines like this, from here to here is basically 1/5 of the total, because the diagonal was divided into 5 parts by these points, and therefore if you draw perpendiculars to the sides, it will also be divided by 5 equal parts. Okay, so that's very important. And the same thing holds true for the top. If you were to draw perpendiculars to the top like that, if I can make them straight, it would divide the top by also 5 equal segments. All right, so to figure out the area of the shaded region, hopefully this is not too messy, I will have to do a little bit of math. So let's do that. All right, let's fill that in as 9. Okay, so now I'm going to first draw out 5 different sections that we need to cut out, and when you cut them out, you get the area of the shaded region. So let's draw those. The first one is this square right here, or actually it's probably a rectangle. Okay, we'll call that 1. The next one is this triangle right here. Call that 2. The next one is this triangle right here. That one. Call that 3. The next one is this triangle right here. We'll call that 4. And finally, that triangle right there. That one. That we'll call 5. If we can figure out the area of 1, 2, 3, 4, and 5 and subtract it from the total rectangle, we get the area of the shaded region. And then don't forget to multiply it by 2, because remember, there's 2 of those and they're equal. All right, should be pretty straightforward. So let's go with this. The total area of the rectangle is 9 times 5, which is 45. Okay, that's the first part. Now, to get 1, 2, 4, and 5, I have to start labeling things a little bit here. So remember, 5 was divided into 5 equal parts. So from here to here is 5 over 5. 5 equal parts, which is equal to 1. And then from here to here, we had to divide 9 by 5, like that, 9 over 5. All right? So this 1, the area of 1, is, because it's a rectangle, it's just 1 times 9 over 5, which is 9 over 5. All right? So that's part 1. Now let's do the area of 2. Well, this is a triangle, so it would be 1/2 base times height. The base from here to here is 9 over 5 divided 9 divided by 5 times 4. Right? Because you've got 4 of these. 1, 2, 3, 4. And then the base is just right here, which is just 1. So this gives you 36 over 10. Now let's figure out 3. 3 is also a triangle. The base, let's say that's the base. That'd be 9 over 5. The height, we can call that the height. That would be 4. Because each of these is 1, so this is 1, 1, 1, and 1, so that's 4. And this gives you also 36 over 10. Okay, that's good. How about 4? 4 is this one here. This is also a triangle, so its area is 1/2 base. Base is the full base, so that's good, that's 9. And then the height is from here to here. Well, what's that? Well, it's 3. Because remember, this is 1, this is 2, this is 3. So we've got 3, and this looks like 27 over 2. And then finally 5. 5, 1/2 base times height. The base, we can call this the base, 5. Height from here to here. And what's that? That's going to be 9 divided by 5 times 3. Because remember, you've got 9 over 5 here, 9 over 5 here, 9 over 5 there. So this looks like 27 over 2 also. Oh, interesting. All right, so now we've got it all. To get this shaded area, the area of the shaded region, we take 45, which is the total, and subtract 1, 2, 3, 4, and 5. So subtract 9 over 5, subtract 36 over 10, minus 36 over 10, minus 27 over 2, and the final 27 over 2. All right? And now it's just a simple calculation. So we've got 45, probably going to need a common denominator. Well, 27 over 2 and 27 over 2 is just 27. And then minus, this looks like common denominator is 10. So this will be 18 and 36 and 36. So this is 45 minus 27 is 18, minus, this looks like 72 plus 18, which is 90, 90 over 10. So 18 minus 9, which is 9. All right. Remember, that's the area of this shaded region. But the shaded region here is double that. They've got 2 of those. So we just take our final answer and multiply it by 2. So 9 times 2, which is 18. So the answer is C for number 16. If n is equal to 7 to the power of p plus 4 and q 5 to the power of q, they've written it so small, and then 2 to the power of 3. If that is a perfect cube where p and q are positive integers, the smallest possible value of p plus q is. All right, let's write this out. We've got this perfect cube, p plus 4 and 5 to the power of q and 2 to the power of 3. All right. Well, this 2 to the power of 3 is not really needed. I don't know why they stuck it in there, because if this is a perfect cube, we can just divide by this and get rid of it, and the result will also be a perfect cube. So what we really need to concentrate on is the p plus 4 and q. The only way this can be a perfect cube is if the exponents are divisible by 3. Okay? That's the only way you can have a perfect cube. So a perfect example is right there. 2 to the power of 3. Is the exponent divisible by 3? Yes, it is. So therefore, p plus 4 must be divisible by 3, and q must be divisible by 3. And they're looking for the smallest possible values. So the smallest possible value of q to make it divisible by 3 is just 3. And then for p plus 4, p has to be a positive integer. So if it's 1, then 1 plus 4 becomes 5. That is not divisible by 3. But if you make p equal to 2, you have 2 plus 4 equal to 6. And 6 is indeed divisible by 2. So therefore, p is going to be 2, and q is going to be 3. And that would basically make this 7 to the power of 6, 5 to the power of 3, and 2 to the power of 3. Now, is this a cube, perfect cube? Well, take the cube root of it to see. If you get an integer, then it's a cube root. Cube root of this is 7 to the power of 2, 5 to the power of 1, and 2 to the power of 1. And this is indeed an integer. So all of our conditions are satisfied. They're asking for p plus q. So p is 2, q is 3, so p plus q is equal to 5. The answer here is A. Q is the point of intersection of the diagonals of one face of a cube whose edges have length 2. The length of QR is. All right, so the first thing we need to do is draw some perpendiculars here. Right there and right there. And this is a right triangle. Right there is the 90 degrees. And I'll label this QR. We'll call this P, and we'll call this S. So if we have this triangle, we can immediately see that QR squared, using Pythagoras, is equal to QP squared plus RP squared. So if we can figure out QP and RP, we can figure out the length of QR. So the first thing is I'll draw this face a little bit better for you to understand, I'll draw it here. And let's draw the diagonals. And this is Q. And this is a square of length 2. So this is 2, this is 2, this is 2. Now, when you draw a perpendicular from Q down to the base like that, that becomes a length of 1. Because you're essentially just cutting the square in half like that. So that's easy. So QP we have as 1. So I'll just put that there for now. So we've got half of the puzzle. Now we have to figure out RP. Well, RP I'll draw out like that. And this is R, this is P, and this is S. Well, PS is just 1 because the full side is 2 and P cuts that full side in half. P is here, S is here, so this is 1. So that's good. PS is just 1. And then RS is just the length of the side of this cube. So that's 2. So we can use Pythagoras to solve for RP. RP squared is 2 squared plus 1 squared. So that's 5 for RP squared. RP is the root of 5. So there you go. You got everything you need. RP is the root of 5. QP is 1. So we can solve for QR. So QR squared is QP squared, which is 1 squared. RP squared is right there, it's 5. And therefore this is 6 for QR squared. And QR therefore is the root of 6. So that would be choice E. Mr. Anderson has more than 25 students in his class. So we'll let X represent the number of students. X is greater than 25. He has more than 2 but fewer than 10 boys. And he has more than 14 but fewer than 23 girls in his class. How many different class sizes would satisfy these conditions? All right. So let's make a table. Boys, girls, boys plus girls, and we'll see what we get. So let's start with the extreme cases. The smallest number of boys is 3. And the largest number of girls is 22. So B plus G is 25. Does this fit? And the answer is no, because the class size has to be greater than 25. So this is no good. All right, so cross that out. So let's keep going here. Let's go to the next one. Boys 4 and girls 22. This is 26, so this works. And similarly, we're going to have to do this to see what are all the different possible class sizes. So if boys are 5 and girls are 22, we're going to get 27. And if the boys are 5 and the girls are 21, we're going to get 26. And then we can't go any lower than 21 for the girls. So we've exhausted that, because if we do, we won't get a class size of greater than 25. So now we've done the 4s, we've done the 5s. The next one is the 6s. So for 6, if we use 22, we'll get 28. If we use 21, we'll get 27. And if we use 20, we'll get 26. All right, we can't go any more than that, because then the class sizes would not work. they won't be greater than 25. And let's just keep going. You can probably do this pretty quickly. Same kind of scenario, 29, 21 gives you 28, 20 gives you 27, and then 19 equals 26, and then we can't go anymore. Let's do the 8s. 22 is 30, 21 is 29, 8 and 20 is 28, 8 and 19 is 27, 8 and 18 is 26, and that pretty much is the end of the story for the 8s. And finally, for the 9s, you'd have 31, 9, 21 would have 30, 9, 19 is 28, 9, 18 is 27, 9, 17 is 26. And I missed a 920 in there. That's 29. Okay? And at this point, that's it. You can't do any more. Why can't you do any more? Well, because B, the number of boys, has to be less than 10. It can't be 10. It can be only between 3 and 9, and we've exhausted all of those possibilities. So what is the question asking? How many different class sizes? So let's look at the class sizes. We've got a class size of 26, 27, 28, 29, 30, 31. And I believe those are the only class sizes. So there's 6 possible class sizes. 1, 2, 3, 4, 5, 6. So the answer to the number 19 is B. Each side of square ABCD is 8. A circle is drawn through AD so that it is tangent to BC. What is the radius of the circle? Okay, so the square has side 8, so that means this is 8. And the circle is drawn through AD, so right here this is A and this is D. And it's tangent to BC. So that means right here, it just touches the circle. The square and the circle meet at just one point. So they want us to figure out the radius of this circle. So if this is, say, the center of the circle, they want this value, the radius. We'll call that R. So let's draw this out a little bit bigger. All right, this is a somewhat replica of the diagram, and we're going to start labeling this now. So let's make this the center, and let's draw some parallels. Let's draw this one here, and let's draw this one here, and let's draw that one up there. And I think that is all we need, and we're going to start labeling it now. So from here to here is the radius of the circle, and from here to here is also the radius. This one and that one. Okay? This is a right angle, and right here, from here to here, is also known because it's 4. Because the full side is equal to 8. And sorry, this diagram isn't exactly perfect, but when you do it, it's going to essentially cut the BC in half. So if from here to here is 8, from here to here will be 4. All right? And therefore, this will be 4 from here to here. And we will call this, we'll have to label those. Up here is also R, from here to here. And therefore, this final part will be what? 8 minus r, because the full side is 8. Okay, so that is how we label this diagram. Now the good news is we can tell a relationship in this triangle right here with the Pythagorean theorem. And we've got 8 minus r squared plus 4 squared is equal to r squared. So we'll solve for this. And this will give us 64 minus 16r plus r squared plus 16 equals r squared. The r squareds cancel. So 64 and 16 is 80. Put the 16r over to the other side. And therefore r is equal to 80 over 16. And r is equal to 5. So the answer here is B.